we are back online. Welcome back for the next video training of the maintenance schedule CHP 6R21B. In this video we have to start to add on some additional information about the conrod and the main bearing. Special on in the situation that you have engines there where the engines got rebuilt or overhauled from Schnell. There are some special informations what must be looked on. Okay, then let's dive in. So here we have the engine number. You can find the engine number on this shield or type shield at the engine block, and we are focusing at the moment on the ending of the engine number. We realized at some overhauled or new or rebuilt engines from Schnell that there are some special items needed if you have to do the 7200 or as well the 14400 maintenance. This is additional information on the number what we get from Schnell. There could be end with a RT or with RTK. So let's have a look what that means. So we have at the engine where the engine number ends with RT. That means we have a overhauled engine. The second information means the engine block tilt out with an oversized cylinder liner. So there we have to keep in mind, if we have to work on the cylinder liners, so in case a cylinder liners get broken, leaked, cracked, and we have to replace it, we have to look always on the engine number. If we find the RT, that means we need an oversize of the cylinder liners. So important to keep that in mind. Otherwise the original one will not fit properly in and will not seal properly. Then we have the ending of the engine number with RTK. So it's the same like RT. So it's a repaired engine. The engine block drilled out with oversized cylinder liners. So here again we need oversize of the cylinder liners. The crankshaft is machinated. That means that the main and connecting rod bearings are the first oversize now. I spoke to Schnell already, and there are only engines out with one oversize in Japan. So that means if we have an engine but the engine number ends with RTK, we have to focus. If we have to do anything on the cylinder liner, we have to be careful that we, in case we have to replace it, we need oversize of the cylinder liner. If we do maintenance at the crankshaft or crankshaft main bearings or conrod bearings, focus on that we need the first oversize for that engine to do a proper maintenance. The case what we had is that we had an engine with actually with RTK on the engine number, and the bearings which we put in was actually the original one, so the standard size. And at the end of the day, after everything was put back together, we had a problem that after trying to start the engine, that the oil pressure of the engine dropped after starting the engine. So that was happened because the gap between the bearing and the connecting rod, the gap was too big. So the oil pressure disappeared because the gap was too big and the oil pressure disappeared. On the crankshaft by himself, if we have to do work on the crankshaft, we have here the work description of the DC12 in English. You will find all this information, how to remove the crankshaft, how to measure the crankshaft, how to measure on the crankshaft by themselves, the exact size. We have all this instruction here in our Scania maintenance or Scania description DC12. You can find it on the page 78 until 81. If you think we have to do a more detailed video about that, please let me know. We can dive into that stuff deeper as well. We are still at the crankshaft. Here it is important that we follow exactly the steps to put the crankshaft back in again, put the bearing in, put the holder on, and follow exactly the instruction of tightening the bolts properly. So here for that bolts we have to tighten first with 50 Newton meters and then plus 90 degrees. So you will find in the Scania document as well the information of the main bearing, of the standard size, the next undersize. They call it undersize because they are removing on the crankshaft the material, and then it is undersized, but the bearing it must be oversized. The same here for the con rod, and as well here there are some additional oversize options for the thickness of the axial bearing washer. Documentation that's called function description of the DC12, and you find more information about the function and how it works in that documentation. You can find it on the page 9 if you are interested to dive a little bit deeper in it. So, crankshaft bearing. The crankshaft bearing is the main friction and the axial bearing. We have it here. So we have the crankshaft bearing sitting here. It's the main bearing, and this is this kind of axial washer. It's works like a washer. So this must be replaced every 14,400 operating hour. So let's here. Important here is we have again the shell, the bearing shell, and with the different layers shown here. And important is actually when we put it back, we should only put oil on the inside and the outside of the bearing, where actually the mounting blocks are connected, should or must be oil free. And again, for sure, the inside where the crankshaft is running, this area there should be oil before we put everything back together. So here we have the axial bearing. So this rod washer is fixed the axial, the crankshaft, so that the crankshaft have not too much space or gap to move from the right to the left or from left to the right. That's the clearance. What is the limitation? And for that washer you can get different oversize as well. So here the crankshaft mechanism, that we have the different torques, the information about the torques, the size of the torques, and as well how to tighten it. Yeah? Here, important that we follow exactly the instruction of the torque, to put the right torque and angle on the bolts. Here again, to remember, renew the bolts every time. The same with the conrod. This is special torque bolts. So if you use them once and you open it again, you have to replace it. If one of this bolt break, it can cause a big engine damage, because if the bolt break, we will lose the hold of the bearing, we will drop the oil pressure immediately, and that can cause damages on the crankshaft, it can cause damages on the conrod, and actually on the whole engine block. So please remember that. Renew the bolts every time. When you open the bolts, don't use it again. Please replace it every time. Ensure that you have the bolts available, and for sure all the other material before you start with the maintenance. So let's go to the next point here. So the cylinder head. The cylinder head have to be replaced every 14,400 operating hour. Or if you do proper measurement, I always recommend to do it every 7,200 operating hour, that we do the compression and pressure loss measurement that show us early enough if we have any problem on the cylinder head valves, or on the liner, or on the piston rings, etc. So if usual the replacement is every 14,400 operating hours. If we do this measurement properly and we can see which cylinder have actually problems, then we don't have to replace all the cylinders. So that's why we usually do the compression measurement and the pressure loss measurement. And if we go through the document properly, as I mentioned already, and use it as a proper report for later on as well, that we fill out all the information what we need in here, and we do the measurement properly, then it will show up as the information which cylinder are in trouble. So in this case, in the showcase scenario here, we can see here the orange and red information on that side, and we have here the limitations of the compression measurement and the pressure loss. So we can see the double indicator that cylinder 2 and cylinder 5 in this case, oh that must be cylinder 5 here, sorry for that, must be replaced. That means we have to check the cylinder head, we have to check the cylinder valves, we have to check the liners or the piston and piston rings, that we know what we have to replace, that we at the end, when we had replaced everything and assembled again, that we put everything proper together and we can operate the engine immediately. On the cylinder head, it's important that we tie the screws with the steps. So that means we have to step 1, 2, 3 and 4. We always mark the screws when you tighten the first step, for example with one stripe or with one dot, and then go further through all screws. So we tighten first with, we tighten first with 60 Newton meter, all screws, mark all screws step by step, that we don't forget one. We go to the next step, we go screw by screw on 150 Newton meter, mark each one after you tighten it with the Newton meter. Then you go to step 3. 250 Newton meter, mark each screw after you tighten each screw. And then we go to the step 4. That means another 90 degrees angle turn of the bolt. Here we have some more information about the tightening of the bolts at the inlet manifold with 26 Newton meter, the exhaust gas manifold with 63, the fuel rail with 20 Newton meter, and the water rail with 20 Newton meter. So the torque is always very important, that we ensure that all bolts are tight, but not too tight and not too loose. So please follow this instruction and then go to the next steps. So then we have the crankshaft idler. Should be replaced every 10,800 operating hour. In the documentation here, there's the number 7 missing from Schnell. So the crankshaft idler is here number 7. That's that one. You can find the direct or instruction in the Scania manual, work description DC12. If you need more details about that, let me know. We can go more and more in detail here as well, but you will find the information how to do the work in the Scania documentation. So furthermore, now we come to the turbo compounder. I had sent you all the documentations already. There is another description as well. There's a turbo compounder work description. You find it in the folder at the Google Drive. So look at this, that you get all the information about the turbo compounder as well. In the meantime, you should know, we're talking about the turbo compounder. There's this unit here. It's connected here to the back on the engine. Here the exhaust gas is running through. It's turning the turbine inside. So here again we have our usual turbocharger. We get the exhaust out of the engine, turns the turbocharger. From the turbocharger goes to the turbo compounder, and that turbo compounder is connected via oil clutch to the backside, and then from the mechanic directly to the crankshaft. So we're using the rest of the pressure and temperature from after the turbocharger, from the exhaust gas, to get an additional 15 kilowatt out of the exhaust gas onto the crankshaft. First maintenance, what we always have to do on the turbocharger is turbo compounder is the shaft and the bearing. So we have here the shaft and the bearing. This must be replaced every 3,600 operating hour. We had on some plants already many problems and high costs because we destroyed the complete turbo compounder. Because we don't have done the proper maintenance on the smaller parts at 3,600 operating hour and as well on 7,200 operating hour. Important is that we have a proper clearance to adjust the backlash, and then we can have a proper clearance that the gears are going nicely in each other and not be under pressure. If we get here under pressure, we get pressure on the bearing as well, so we can damage bearing and shaft. The next thing will be check injector nozzle that is free and direction directly on the bearing. If you can see actually if the bearing get hot because of the bearing get old, or the gaps are too big, or there are some problems, then it's starting to get hot, and you remember when steel changed the color, then it's a sign that this area get too hot, and we should replace it immediately before we get any problems on the bearing. If the bearing breaks, the shaft can break, and then the complete turbocharger, turbo compounder can break. Here we can see the nozzle. This is the oil nozzle, actually, what sprays oil onto the gear and onto the bearing. That's very important that we use here the right bearing. So this open housing bearing, so that the oil can go into the bearing. There's two things. One thing is we give more oil so it can run easier. The next thing is we get oil which can cool down the bearing. So that's very important that this is running nicely, and that we do the maintenance of the bearing and the shaft and check the nozzles every 3,600 operating hours. At 7,200 operating hours, we have to replace the turbo compounder. So I have many systems running. If we do a proper maintenance, we can extend this operating hours. This is a standard from Schnell that says, okay, we have to replace the turbo compounder every 7,600 operating hours. I have systems running with over 10,000. If we do a proper maintenance on the bearing, on the shaft, and ensure that we have a proper cooling from the oil nozzle, we can actually extend that. But if we keep monitor the shaft so that we can see if the bearings are still working nicely, that the bearings is running soft, smooth, and if we can see that there is, if the shaft is still fine, then we have the option that we say, okay, we can run longer than the 7,200 operating hours, but the bearing and the shaft and the nozzle always must be checked, replaced at 3,600 operating hour, and we save a lot of cost and time and damages on the turbo compounder. Yeah, okay, so we have this instruction. Please have a look on the turbo compounder work description as well. And if there are further questions, please let me know. Okay, jump to the next. So this is actually on the opposite side of the compounder. We have the idler, this is the gear here. We have the compound idler, this is that one. That connects actually the compounder and the crankshaft with each other. This must be replaced and checked every 10,800 hours. You will find the work description in here. And if you need more information about that, please let me know, and we can prepare the stuff for you. Okay, exhaust gas system. First thing is that we actually have to always inspect the exhaust gas system, that we ensure that every 3,600 operating hours that we check the exhaust gas system if we can see any leakage or something else. So we have number one. Oh, the number is very bad to see. We have here at the top piece of the silencer, the piece here on the bottom, we have a condensate nozzle, so we can open that nozzle, we can release if there is condensate inside of the silencer. Usual the condensate return flow line, that's that one here, connected. So the condensate usual, but we have to check if this is blocked, then condensate will fill up in the exhaust gas silencer. Usually the condensate will come down here, goes back into the pipe. The heat of the exhaust gas will move a lot of condensate out of the exhaust gas pipe again, but still there could be enough condensate running back. And there is an optional condensate nozzle on the bottom as well. So in case we get here condensate, the condensate can get out here. Always remember, in the condensate, in the exhaust gas, you can have a lot of dirt stuff as well. Especially if we operate with a high H2S content, for example, or with other poison stuff in the gas, what can force that we get stuff into the condensate, and then it can start to block that connectors or the nozzles as well. If you have, for example, if you have a lot of or if you get some damages on the engine, for example, a turbocharger break or a turbo compounder break, especially on a turbocharger, and you get oil in the exhaust gas pipe, that can then start to block pipes or connectors, and then, as we should know already, in the exhaust gas we should not get too high back pressure onto the engine or onto the turbocharger. That's why we always have to check every 3,600 operating hours that the nozzles and the connectors are always cleaned. And I recommend to do exhaust gas measurement at least every 7,200 operating hours, so that we know what is the back pressure on the system, and know if we have any blockage or damages inside of a silencer, to ensure that we not get further problems on the engine. Here we have the standard inspection of the CHP. You will find in the documentation of the manual, Schnell manual document BA 6R20 1B. You will find all the information about the Schnell CHP, and then you can go through that inspection as well. First of all, we looking on the CHP unit control panel. So the control panel is the panel where the panel PC is settled. We have to check and clean that filter and that filter. You'll find in the Schnell manual the the instruction how to open it. There's a click. You can open the front side, then you will fit inside a filter inlet. You can clean that first time. If it's getting too dirty, you have to replace it. Then we have the next one is cleaning the alternator power regulator board. If you look from the side, the power board, or the regulator, the AVR, you will find on the back side. So the alternator in front will be the engine, and here on the back side this is the control unit for the voltage control of the alternator. If you clean that out, please always ensure that the system is not operating, and if you clean it, only use an air compressor, so that you clean that area out, that all the dust goes out, and that not the regulation can get any problems. Okay.